So next up, I'd like to do an example involving the equation of a circle in standard form. The equation that we have is x plus 2 quantity squared plus y minus 6 quantity squared is equal to 16. I'd like to do this in 3 parts. So first, because it's already in standard form, one that should be fairly straightforward for us is going to be to identify the center and the radius. Now, as we said in our previous movie, YouTube short, whatever, whatever number you see inside the parentheses with your variable, the coordinate for the center is going to be the opposite of what you see. So, for x plus 2, we can count on seeing an x-coordinate of negative 2. And for y minus 6, we can count on seeing a y-coordinate of positive 6. Now, as far as the radius is concerned, this number over here, this positive 16, is supposed to be r squared. So to find the radius, we take the square root of that. And once again, it's not necessary to do plus or minus a square root because a radius is referring to a distance. So we'll just take that as positive 4. For our second part, what I'd like to do is graph the circle. Now, to graph the circle, I would recommend that you do this in terms of 4 points. And the 4 points that I'd like you to use is starting from the center. We're going to go up, down, left, and right, a total of 4 units. Now, for the center, the x-coordinate is negative, the y-coordinate is positive, so we're going to draw this with a special emphasis on quadrant 2. So we'll go 1, 2 to the left, and 1, 2, 3, 4, 5, 6 in the upward direction. Now, this point isn't actually on the circle, but I still want to call reference to the fact that negative 2, 6 is a significant point for the circle. So starting from this point, I would like to go up 4 units, and going up 4 units, we will be able to place an ordered pair here. At negative 2, we just went up 4 units, so I'm going to add 4 to the y-coordinate. We'll call that negative 2, 10. For the down direction, starting from the center, once again, 1, 2, 3, 4. Oh boy, I think this one's going to be a little bit lopsided, and that's okay. Negative 2, 6, we went down 4 units, so I'm going to subtract 4 from that 6 and wind up with positive 2. Then for the right, we're going to go 1, 2, 3, 4 units to the right. Oh yeah, a little disproportionate. So that's going to add 4 to the x-coordinate. Negative 2 plus 4 is positive 2. And the y-coordinate stays at 6. And then 4 units to the left, 1, 2, 3, 4. That would be subtracting 4 units from the x-coordinate, giving us a point at negative 6, positive 6. Try to draw something relatively round that passes through all of these points, and you will have yourself a decent-looking circle. Now, with that in mind, there are, of course, ways to improve the way that this is done. For example, making use of some sort of software or technology to make it look all pretty. Now, to tie this into concepts that are prerequisite knowledge, I would also like to find all of the intercepts. Now, intercepts are defined as points where the graph of a relation hits one of the 2 coordinate axes. Now, based on the fact that we have an an x-axis and a y-axis here, it appears as though we have 2 separate y-intercepts, but the circle never makes it so far down that it actually hits the x-axis. I'd like to demonstrate what that's going to look like. So let's start with the y-intercepts because I can see that those actually exist. So the process is we're going to set x equal to 0. Now, by set x equal to 0, I mean go back to the original relation that was given to you. We're going to set x equal to 0. So setting x equal to 0 will give us 0 plus 2, quantity squared, plus y minus 6, quantity squared, is equal to 16. Now, we already have a completed square in the form of y minus 6 quantity squared, so I'm going to try to get that by itself on one side. So first thing I'm going to do is do 0 plus 2 and then square that result. That'll give me positive 4. Oh, excuse me. Just ate some delicious wings from Detroit Wings Company and had a little something stuck in my throat. So subtract 4 from both sides. We have y minus 6 quantity squared is equal to 16 minus 4. That'll be 12. Take the square root of both sides. Applying the square root property, this will be plus or minus the square root of 12. Now, if you can simplify this radical, you should do so. 12 can be split into a 4 times 3. Square root of 4 is 2. Square root of 3 stays as the square root of 3. To finish solving for y, we are going to add 6 to both sides, and we'll get 6 plus or minus 2 square roots of 3. These are not like terms, they are not like radicals, therefore we are not going to try to combine them. So the y-intercepts are going to be, we set x equal to 0, so x-coordinate 0, y-coordinate will be 6 plus or minus 2 square roots of 3. And that's approximately what we see from our graph up here. 6 was right here. If we go plus 2 square roots of 3, that puts us up here. And if we go minus 2 square roots of 3, that puts us down here. Good stuff. Now, I can see from the graph that we drew that it seems very unlikely that we're going to find any x-intercepts. I just want to demonstrate what's going to happen if we do try to find them. So for the x-intercepts, this time we are going to set y equal to 0. And in setting y equal to 0, once again, we're referencing back to the original equation that we had up top. I'm going to take this, I'm going to set y equal to 0. We are going to get x plus 2, quantity squared, plus 0 minus 6, quantity squared, is equal to 16. Now, the algebra after this is going to be very similar to what we did for the y-intercepts. Simplify this square. We'll get x plus 2, quantity squared, plus squaring negative 6 gives me positive 36. And that's still equal to 16. Subtract 36 from both sides, and we are going to arrive at x plus 2, quantity squared, is equal to negative 20. Now, it's not that this equation doesn't have solutions. It actually does have two solutions, both of which are complex numbers. Now, because they're complex numbers and not real numbers, that's how we know that there's no real solution. When we talk about x-intercepts, keep in mind that the x-axis is referring to all real numbers. So we can conclude that this has no real solution. Therefore, we have no x-intercepts. So the way that we can show that this has no x-intercepts, there's really two ways. This would be the graphical way, or the geometric way to show. And this down here would be the algebraic way to show that there are no x-intercepts. As far as I'm concerned, they are both equally valid.